Now we are going to put together our quadrilateral, or a book of quadrilaterals, or quadrilateral flip book, as it's sometimes referred to. So it's going to look something like this, and it's important that we put it together correctly, otherwise it can get very confusing. It should be copied all together the way it's supposed to be. So what we want to have is we want to have the kite, the trapezoid, the square, the rhombus, and then when we fold over, we should have rectangle, parallelogram, and then classifying polygons, and then our title. So go ahead and fold that all up and staple it, and then we should be ready to go. Okay, now that we've gotten our book of quadrilaterals all set up, we are ready to go through and fill it out. So the first flap that we're going to go through, the first page, is classifying polygons. And there's a couple different ways we can classify polygons. The first is regular and irregular. So regular polygons, all sides and angles are congruent. So that's like a square. So we can have regular triangles, that would be an equilateral triangle, or you can have regular pentagons or hexagons or anything like that. Irregular, not all of the sides and angles are congruent. So this will become important when we start talking about interior and exterior angles of polygons. But there's two different ways. Typically, most of the polygons we're going to deal with will be regular. We can also classify them as concave or convex. So concave, I always remember this because it's caving in on itself. It has a point on the interior of the polygon. Convex, you see all the points are poking out. Nothing is inside the middle of the polygon. And we can also classify polygons by the number of sides that they have. So you can see I have 3 sides as a triangle. 4 would be a quadrilateral. 5 is a pentagon. 6 a hexagon. 7 is a heptagon. 8 is an octagon. You can remember that because an octopus has 8 legs. An octagon has 8 sides. 9 is a nonagon. 10 is a decagon. 11 is an undecagon, and there's another one for 11 that I can't recall at this time. I'm sure you can Google it. 12 would be a dodecagon. After that, we're just going to call it a, say it has 25 sides. We'll call it a 25gon. I'm sure there's proper names for that, but it gets a little complicated. These are the main ones that you're going to want to try to remember. So go ahead and pause the video, copy this down so you'll have it handy. So the first quadrilateral we're going to come to is a parallelogram. And we have learned about these different shapes forever. I remember my kids in preschool would come home and they would know what a trapezoid was or a parallelogram. The difference is now that we're in geometry class in high school is we're learning more details. Again, my kids learned about these. My daughter has a song about all of these different shapes that she learned, in 1st, 2nd, 3rd grade. We're just learning the concepts a little bit deeper. So the properties, so if you want to jot down this picture shows all the properties. The properties of a parallelogram: opposite sides are parallel. So these are parallel, these are parallel. Opposite sides are congruent. That means they have the same measure if you don't remember. Opposite angles are congruent. Consecutive angles are supplementary. These 2 angles are going to add up to 180 degrees. And these 2 angles will add up to 180 degrees. And then the diagonals bisect each other. They're going to cut each other in half. Theorems, basically we're taking the properties and we're putting them into a conditional statement, an if-then statement. So we can prove these theorems. Now we're going to go on to rectangle, and somehow my rectangle really looks like a square. So you please feel free to make this look more rectangular. A rectangle is going to have all the same properties as a parallelogram. So a rectangle is a parallelogram, but it's a more specialized parallelogram. The diagonals are congruent. So from the corner to corner is the same here as it is here. And then it has 4 right angles. A parallelogram doesn't necessarily have to have 4 right angles. Now we're going to go on to a rhombus. And a lot of people remember a rhombus because it's kind of like a square that's been squished. All of the sides are going to be congruent. So it has all of the properties of a rectangle. As a parallelogram. And all of the sides are congruent. The diagonals are perpendicular, so we get a right angle right here. And remember, whenever we see a triangle with a right angle, we can use Pythagorean theorem, or we can use our trig ratios if we know angles. But Pythagorean theorem comes into play with quadrilaterals a lot, so keep that in mind. And the diagonals bisect opposite angles. And then here's our theorems right here. Next, we have a square. I think everyone knows a square. A square is also a parallelogram, a rectangle, and a rhombus. There's some things to note about squares. Since we have 90-degree angles and the diagonals bisect those angles, we get 45s here. And when we have 45s, we get a 45, 45, 90. So we can apply our ratio for 45, 45, 90 triangles to this portion of our square. And I wrote that in here. The ratio is x to x square roots of 2. So that's a really cool thing just to keep in mind. It also applies to this triangle. We can use the diagonal as our x square roots of 2, and then our side is our x. Next, we have a trapezoid. Trapezoids are a little strange. We have one set of parallel sides called our bases. And then these two over here on the ends are called our legs. When we have an isosceles trapezoid, these two will be congruent. And you can remember that because isosceles triangles have 2 congruent legs. So does an isosceles trapezoid. We have this mid segment in here. And then we also have base angles. The base angles that go with the top base are congruent when we have an isosceles trapezoid, and the base angles that go with the bottom base are congruent when we have an isosceles trapezoid. And our last quadrilateral that's special is a kite. We have 2 pairs of consecutive sides that are congruent. So these 2 sides up here will be congruent, and then these 2 sides down here will be congruent. And the diagonals are perpendicular. So again, that gives us that right triangle. So we can use Pythagorean theorem on this. Pythagorean theorem is super important. If you don't remember, it's a squared plus b squared equals c squared.